Today we are on page 20, which is a left side, which is different than usual, okay, because it's only one page of notes and I'm not leaving a space for like an entry task or anything. So page 20, again, left side, and the title is Graphs of Functions. Okay, so here we are on page 20. Again, that's the left side. If I were to open it up, the spiral would be in the middle over here. It's Graphs of Functions, and then you'll either be doing this on the 29th or the 30th of this month. The learning target is that I can analyze and compare graphs of functions. Okay, and just to again start off, I always like to do a little vocabulary so we know the right terms that I'm going to be using. So firstly, starting point. A starting point is where the graph touches or crosses the y-axis. Okay, it also will have a significant meaning in the problem situation as well. Then we have steepness, and this refers to the angle of a line as it increases or decreases, and this refers to the rate in a problem. So steepness has to do with, like, if the angle is higher to the ground, then that would be more steep, and if it was closer to the ground, that would be less steep. And the same thing follows if it's going downward or decreasing. It would be more steep or less steep. Okay. Then we have the words rising and falling. So a rising graph means that the points or line goes up from left to right, and a falling graph means the points or line goes down from left to right. Notice that it's always from left to right, just like reading a book. So here is how it works. Notice that if we were to start with the leftmost point, we would need to go up and then over, and I'm color coordinating on purpose, and then up and over. So in this scenario, these ups are the dependent variable, okay, because they're going parallel to the y-axis, which is where the dependent variable would be. And then these to the rights are the independent variable because they go parallel to the x-axis, and that is the independent variable. So what we would say is that the dependent variable, which I'm abbreviating to dv, increases because it was going up. So I'm going to put, the word up in parentheses. As, so again, we have that kind of phrasing like our verbal representation, as the independent variable, so I'm going to write the IV for independent variable, increases. And why is the independent variable increasing? Well, because it's going toward the right. Okay? So, in this case, if a graph is rising, the dependent variable increases as the independent variable increases. Okay? Well, now let's look over here. Again, you have to start with the one that's furthest to the left, just like we read a book. So if I start at the leftmost point and go to the next one over, I have to go down this time and over to the right, and then down again and to the right. Notice that the amount that I go down and up is not the same every single time. That's okay. The amount that I go to the right every time is not always the same. That's okay. So again, these green or horizontal lines that go towards the right, those are your independent variable. And these ones that go up and down are parallel to the y-axis, so that's your dependent variable. So here, we would now say that the dependent variable decreases, and the reason for that is because it's going down, as the independent variable increases. And that is because it's going to the right. Now notice, in both cases, the dependent variable can change, that it can increase or decrease, but the independent variable will always increase because you always do it from left to right like you're reading a book. So what we want to say about this is that the IV will always increase because we go, and I'm just going to say L to R, which means left to right. Then just to kind of separate that from everything else, I put a little cloud around it. So that's why that happens. Now notice that for the rising one, the dependent variable increases, and for the falling one, the dependent variable, this one increases, this one decreases. So the dependent variable is what tells us whether it rises or falls. So this is the reason that it is a rising graph. And this one is a reason it is a falling graph. Okay? So the independent will always go increasing because it's going to go from left to right. The dependent, on the other hand, is the one that can change from increasing to decreasing, and that's what changes whether it's a rising or a falling graph. Okay, so now let's look at a scenario. Okay, so two families are filling their pools to a height of 12 feet. Okay, so we're going to talk about this not in volume, but like the height of the pool. It doesn't matter if they're the same volume or not. That's just what we're going to look at. Okay, so we have two scenarios. Family A. Family A's pool will start with 7 feet of water and raises 1 foot per hour. All right, so here we go. We start with time. So we know that at no time passing, it's already 7 feet full of water. Okay, so we don't know if they never emptied it all the way or if they did filled it a while ago and never finished or whatever. But then every hour that passes, they add 1 more foot. So this becomes 8, and then 2 hours becomes 9, 3 hours becomes 10 feet, 4 becomes 11, and 5 becomes 12. Now I'm stopping at 12 because that is what they tell us. They want both families to fill the height to 12 feet. Okay, so what is really happening here? Well, we start at 7, so I'm going to go to 1 hour first. 7 plus, and then we're adding 1 foot per hours that have passed. So here, maybe I should do this in a different color. There's my purple. There it is. Okay, so because at this time only 1 hour has passed, it's 1 foot times 1 hour. And that gives you 8 because it's 7 plus 1. Then we have, again, we start with 7 plus 1 foot per hour. And if 2 hours have passed, then that's 7 plus, and that multiplies to be 2. So that's 9. And then 7 plus 1 foot per hour times 3 hours, okay, which makes 10. 7 plus 1 foot per hour times 4 hours, that's 11. And lastly, 7 plus 1 foot per hour and 5 hours have passed makes 12. There we go. So now, if you didn't notice, I did add these variables up here. So I have lowercase t for time and h for height. And because we want it to be in function notation, this becomes h of t. Remember, the input goes in the parentheses here. Okay? Perfect. So now we have this. And if it helps you, so now we have this. Remember, we keep everything the same that stays the same all the time. So here, 7, 7, 7, 7. So we're going to have 7 plus 1 times, and then dun, 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 this always matches the this column here identically, so we're going to put a T there. Okay? And if you notice, you're like, Miss Azor, you left that row blank. It works for that as well because you have 7 plus 1 times 0 hours passing. Well, 0 times anything is 0. So 7 plus 0 is 7. So it ends up working out. So here we now have our function notation. Okay? So there is that. Now let's do the same, but for the other family, family B. Family B's pool starts empty and raises 2 feet per hour, or rises, or whatever. So at 0 time passing, it's empty. So that is 0 feet high. Okay? And then 1 hour passes, we add 2 feet to the height. So that's 2 feet. And then 2 hours, we put another 2 feet. That's 4. 3 hours is another 2 feet. That's 6. 4 hours, another 2 feet. That's 8. 5 hours is 10, and 6 hours is 12. And again, I'm going to stop there because they only want to raise it to 12 feet. Now, because we are starting with 0, you can write 0 plus, or you don't have to write that at all because adding 0 to something doesn't change it. But now I'm doing 2 feet per hour. So since 1 hour has passed, we would do 2 times 1, and that gives you 2. Then you can do 2 feet for 2 hours, and that would make 4. 2 times 2 is 4. 2 feet for 3 hours makes 6. 2 feet for 4 hours makes 8. 2 feet for 5 hours makes 10, and 2 feet for 6 hours makes 12. And remember, the same works up here. 2 feet for no hours will make 0. And I'm just going to go ahead and write here that this is optional. Oops, not a B. Because plus 0 doesn't change. And some people will like the plus 0, some people won't like the plus 0. It just kind of depends on who you are. I always say if it makes you feel better to write it, then write it, because if you forget it, then you might miss the problem. So sometimes it's better just to have it there so you know that it's there. You remember it. Okay? So optional because plus 0, not the number 2. Plus 0 doesn't change anything. Okay. So now again, if I use T and H, here in the H of T, Miss Azor, use your function notation, please. You're welcome. This would just be 2 times T, because it always matches the time in the parentheses. It's just the exact same number, so you shouldn't have to do anything else. And there is our function notation. And again, if you want to, I'll put like a dashed 0 because it is optional. So you don't have to write it, but you could write it. Okay, so now we have our 2 scenarios, but this is all about functions and their graphs. So now we have our 2 functions. Let's look at a graph. So when you come back, you will see my coordinates set up. All right, so here are my coordinate planes or graphs set up. Notice that I have the independent variables on the x-axis, time and in hours, because I know the units, and that's x. And then I have my dependent variables on the y-axis, which is height and feet, because I know the units on that, and this is y. Okay. And lastly, that I made sure to scale it to the numbers that were appropriate for this problem. So I know on this one, the y The x-axis goes out to 5 at a minimum, and this one goes up to 12, and then over here the x-axis needs to go to at least 6, and the y-axis needs to go to at least 12. Okay? So there we go, we have it set up. From here, we just plot the points. So the first one, 0 is 7. So these are actually, every 2 spaces is 4. That means it's 2, 4, 6, 8, 10, 12. So 7 is going to be right in between 6 and 8. So it's right there because I made each space be 2. And then after 1 hour, we'll have 8. So make sure you go over fully to 1 and up to 8. And then 2 hours will be 9. 3 hours will be 10, 4 hours will be 11, and 5 hours will be 12. So if we graphed it, it would look kind of like this, and then there it would just kind of flatline because that is the height they want the pool, so they would stop filling it. Okay, try and make my points a little bit bigger. Okay, and there you go. Now, notice I connected my points. The reason I did that is because time and height are 2 things that are measured, which makes this continuous. And that's also because if you think about it, it's hitting every single point. Between 7 feet and 8 feet, every single measurement between those 2 things is being hit because the water is slowly rising between those 2 things. It doesn't just jump from one thing to the next. So it's a continuous graph. Now let's look at this one. So now when this one starts, it's at 0 because it's empty. And after 1 hour, it raises 2 feet. So again, I have my scale the same, so each of these squares vertically is 2. Then over 2 hours, we go up 4. Over 3 hours, we have 6 feet. After 4 hours, we have 8 feet. After 5 hours, we have 10. And after 6 hours, we have 12. So again, we have this line, and again, it flattens off at 12 because the pool is now full. Okay, great. So now we have these 2 graphs, and we want to analyze / compare them. Sorry, let me zoom out just a smidge. So essentially, I'm just going to bring it back up to the top section. And notice I didn't do the dashed line all the way down because I'm going to talk about these things together. So the first thing I talked about up top was starting point. Okay, so notice here, this is our starting point for family B. And this is our starting point for family A. But what does it mean? So you have to think about what that means in a specific problem. So if you think about the roses that you did in class last time, you wouldn't buy 0 roses, there would be no cost. So the where it crosses the y-axis would be the service charge, because that's the charge that doesn't apply to the number of roses. It's the charge that stays the same all the time. Well, but in this case, we're talking about the height of the pool. So this is the height when no time has passed, which means it's how full the pool was when you started filling it. So we want to say that, but we also want to compare these. So we could say something like family A, I'll just put a bullet point. Family A has a higher starting point which is my buzzword, so I'm going to underline it. It's the important part. Which means it started with more water. Yeah, we'll see if that works, but there you go. So it started with more water in it. Okay, that's what that means. Then we have the thing called steepness, remember? And that's kind of the angle at which it's going. But we can, again, think of it, you always want to look from left to right. So if I go from like 1 hour to 2 hours, notice here it goes up and over. Now, do not tell me that that is half of a foot, because remember the way we scaled it, this is 1 foot, because each square is 2 feet, so half a square is 1 foot, and then 2 squares here is 1 hour. So for family A, we go up 1 and over 1. Over here, oops, I should have done it from 1 foot over there. There we go. So that I did it between 1 hour and 2. It doesn't matter, but just for consistency's sake. Okay, in this case, it goes up a whole block, which is 2 feet, and over 1 foot. Okay, so what that means is that because this one is rising more in the same distance, this one for family B is steeper. So that means family B's graph is steeper, and that's the important word, so I'm going to underline it. And we're going to say up 2 over 1 instead of up 1 over 1, which means, now remember, if we go all the way back up to steepness, remember I wrote that word rate. So that means that the rate at which it's filling up is more, greater, or in this case we would say faster because it's in terms of time, which means the rate the height changes is faster. Oops. Okay, so steeper means faster or more. Less steep would mean slower, right? So both of these you could flip and say the other way. We could have said family B has a lower starting point, which means it had less water to begin with. Here we could say family A's graph is less steep, which means that the rate is at which it's filling is slower. So both of these have like 2 ways of phrasing them. Okay. Then we, if you have a highlighter, I would get a highlighter. I would do 2 colors. I'm going to do green and blue, shall we? Okay, because I'm going to color coordinate some things. So here is a thing that we want to be aware of, and that is I forgot. Let's just write this down real quick. This here, remember how the lines flatten at a certain point? That's because at that point they are now full. So we want to say, if you were to interpret the graph, here is where they started amount of height, and here is where they're full. So family A's pool is full after 5 hours, and family B's is after 6 hours. Now, this is important because notice, I've already told you family B's is filling up faster. So you would think that theirs would be done first, but actually family A's was done after 5 and family B's was done after 6. So this little bit of information is actually really important because even though this one's steeper and it's rising more, it is affected because their starting points were at different locations. That's important, okay? At some point, if the lines were to keep going, this one might surpass this one, but since we had to stop at 12, we have this different scenario. This one was still full faster, okay? Then if we look at these, if we talked about starting point, steepness, and now I want to talk about rising or falling. So now, if you looked, we've already kind of looked at this from left to right. If you were to walk along it, you would be going uphill, which would make these both rising. So both graphs are rising which means the height of the pool increases as the number of hours increases. So I took that sentence frame from way up top and used that because here we have the height of the pool is the dependent variable, because if you look, it's on the y-axis and it's the second column. And then over here we have the number of hours, and that is the independent variable because it is on the x-axis and it's the first column. Okay, so that would be the structure of which you would say this. If they asked you what the relationship is, you could say that the height of the pool increases as the number of hours increases. Okay, so now I'm going to take these highlighters that I mentioned before, and I changed my mind. I'm going to use blue and pink. I know, Miss Azor, come on. Okay, and that was because I wanted to talk back about this. The starting point here, which is already in pink for me. I wanted to make a little reference here that it's here and here on the graph, which we've already marked. But I also want to point out that notice that this is 7. That is also in our function notation as 7. And here it's 0, and notice it is also 0 over here. And then in addition to that, it's in our word description up here where they tell us that it starts at 7 feet, and over here when they say that it is empty. Those are all of our starting points. So I used pink to kind of show this connection between all of these things. You can see it in the word problem, you can see it in the function notation, and you can see it on the graph. And then I can use it as a description to analyze or compare these two graphs. Then the same thing applies when we talk about steepness. Okay, and so I highlighted that with blue. So I want us to look here that here we have our up 2 over 1 and our up 1 over 1. Well, that is the same as the 2 here in our function notation and the 1 here in our function notation, right? 1 over 1 is 1 and 2 over 1 is 2. And then also it is in our word problem here where we have 1 foot per hour, and notice I did that whole thing, and here I have 2 feet per hour. Okay, so there's all these connections that are going on in our function. The things are not random, they're all tied together, and here is some ways to analyze and be able to describe the graphs. In this case, they both happen to be rising. We can compare their starting points, we can compare their speed or steepness, right? We can compare when they reach a certain amount, which in this case was when did they reach 12 feet, and then we can talk about whether they're rising or falling. Okay, so there is that. Tried to make the notes a little bit shorter. I hope that they worked that way for you, and I will see you guys in class.